Fusion comes in two forms, hot fusion and cold fusion. We're working on hot fusion in a very large reactor in the south of France, ITER. The Western world has poured all of its resources into this single hope. There's no prospect of any energy coming out of a hot fusion reactor, at least not out of ITER, until well into the 2030s. So that is not going to solve our problem.
While delivering hot fusion to customers is still a dream for another day, a low-energy nuclear reaction, once dismissed as cold fusion, might be nearing application for the general public. Companies like Brillouin Energy are beginning to generate interest in their technologies of creating a fusion reaction without needing to generate millions of degrees of heat.
It can be demonstrated in the lab, not easily, but it can be demonstrated, but it has been demonstrated is a more important statement. So the existence of a nuclear level heat effect in the deuterium-palladium system is unquestionable, and anybody that reviews the literature, understands what has been done, will come away with the conclusion that there is a nuclear level heat effect. So Fleischmann and Pons were right.
In 1989, renowned electrochemist Martin Fleischmann and Stanley Pons announced a nuclear reaction at room temperature. But when other scientists failed to replicate their experiment, cold fusion was pronounced dead.
And the scientific argument against cold fusion pretty much goes like this. Back in 1989, it was proven to the satisfaction of the scientific community that the experiment wasn't reproducible. And questions were asked as to how it could work. And it was pointed out that it was that the effect itself seemed to go against conventional nuclear physics. Scientists tend to be very conservative lot, and so if it's the case that cold fusion is perceived to go against scientific theory or earlier scientific experiments in nuclear physics or hot fusion, then there will be reluctance to accept the results.
We tried for years and years, decades in fact, to science this thing into existence, to do good experiments, to publish in good journals when we were able to do so. Robert Goddard approached me probably 3 years ago now. He said, we have a system that can be controlled. The control was by a subtle means of current pulse, but they were able to demonstrate to my satisfaction that they could turn the effect on, turn the effect off, turn the effect up, which is obviously what you need for any commercial object.
This is the next generation wet boiler. So this is basically 2-liter vessel. We fill it about halfway with electrolyte. It's designed to produce about 30 kilowatts of thermal energy. That's enough power to heat the average US household.
This is proof of a cold fusion reaction.
Right. And now I'm going to turn on the electrolysis. And in just a couple of seconds here, the water will heat up enough that it can no longer pull the heat off, and you can hear the sound starting to change. And in just a couple of seconds, you'll see little flashes of light, which is actually destroying the core. You can see sparks are starting to actually form because as the water gets hot, they can't carry the energy away fast enough. You can see sparks sort of forming sort of on a regular basis back all along the surface of the core.
One of the questions that comes up frequently is, well, if this is a true phenomenon, why isn't it seen in nature? And I was very proud of Robert Goddard because he didn't miss a beat. He said, well, you get your oil from Russia and you have fluidized beds to convert it, right? I said, yes. He says, well, don't you see these massive heat excursions randomly? He says, that's LENR, and you could have heard a pin drop. I said, it is found in nature, isn't it? He said, yes, it really is. It's not something new, we just didn't know what it was.
But cold fusion has some wonderful advantages. It has shown itself so far to not have any significant amount of nuclear byproducts, so it's safe and safe forever. It has really no economy of scale. It works on the home scale, so the average home in the United States consumes, let's say, 10 kilowatts, thermal and electrical. We can build cold fusion reactors potentially on that scale. and meet the demand home by home. So everybody can go off the grid or get connected by the grid to improve the stability of their power resource.